If we want to explore the unknown world outside our solar system, and even within it, traveling at the speed of light can be one of our best solutions. But if, for example, we could travel at the speed of light, what would that journey be like? Our fascination with sci-fi movies about space and human travel between galaxies gets us excited. However, the reality is that the distance between galaxies is so vast that such journeys are still confined to those movies. This is because traveling from one galaxy to another requires a speed close to that of light. New science tells us that achieving such a speed is impossible. But if we assume that we could reach such a speed, how would our journey be at that speed? Please stay with us until the end of the video. Imagine yourself in a spaceship that's flying away from Earth. The speed of the spaceship keeps increasing, getting faster and faster. What would we see if our speed becomes really high? And if we want to go even faster than the speed of light, like in those futuristic movies where time bends, what would we see then? To answer all these questions, we need to take you on a space journey and explore new phenomena in the universe. We'll dive into the world of space to better understand what it's like to travel at the speed of light.
2, 1, 0, and liftoff of Space Shuttle.
When the flight begins, we need to increase our acceleration more and more until we feel like we've distanced ourselves from Earth. We imagine that our propulsion system allows us to continuously accelerate. We have to increase both acceleration and speed. You might think that this high speed would be unbearable, but it's not the case, and it has almost no effect on our bodies. And only these physical effects on the body occur when rising from Earth, which is referred to as the G-force effect. For a better understanding of this matter, picture yourself in a high-speed train. You are comfortably seated, moving at an extremely high speed and eagerly awaiting your destination. In this train, you only feel the initial acceleration, and the pressure is mostly on your seat, not on you. This pressure is manageable and exists throughout our entire journey. Everything is going well. But the first danger that threatens our journey is the possibility of a small particle colliding with us at such high speed, which could cause significant damage. Fortunately, our spaceship is equipped with a force field system. This force field is designed to deflect potential collision threats and allows us to navigate freely in space. As we accelerate, a phenomenon called the aberration of light becomes apparent. The stars in front of us gradually appear to move away as we move towards them, making it seem like the sky in front of us is contracting. For a better understanding, imagine yourself in a car moving rapidly in the rain. If you focus on the front windshield, you'll notice more raindrops hitting it, but on the rear windshield, it seems like there's less rainfall. Now, in our spaceship, we observe a similar effect. The sky in front of us seems to contract and becomes brighter, while behind us, the sky widens and darkens. To better grasp this concept, picture yourself in a submarine moving in the ocean. The ocean waters represent the intergalactic space, and as the submarine's speed increases, the water in front of you contracts, taking on a curved shape as if everything is converging at one point. Meanwhile, behind you, the water is expanding. This is due to the phenomenon known as the aberration of light. As we move farther away from Earth, waves also reach us from a greater distance. If we look at Earth through a telescope from our spaceship, we'll observe that people on Earth move more slowly, and the Earth appears to be redder to us. However, when we look at the stars in front of us, we realize that they appear bluer. This phenomenon is the Doppler effect, and time also passes more quickly on planets facing us. For a better understanding, imagine the sound of an ambulance approaching you. As the ambulance gets closer, the pitch of its siren is higher than when it is moving away from you. Similarly, the colors blue and red in stars often indicate whether they are moving closer to us or farther away. As we continue forward and reach speeds close to that of light after several months, the effects of physics start becoming apparent, and the first physical effect that emerges is time dilation. Our universe is a vast four-dimensional space where time and space are moving towards the future. When we, with our spacecraft, distance ourselves from Earth, our path gradually deviates from the future. The path of time separates from space. At this moment, if we decide to end our journey and return to Earth, we'll observe that our wristwatch shows a different time compared to the people on Earth. Our age would have become different from the people on Earth. Another phenomenon that becomes apparent is length contraction. When we move through space at the speed of light, the entire universe is advancing behind us, and the space around us is contracting. However, from our perspective, it appears this way, and the time it takes us to reach our destination is much less than we thought. This allows us to cover thousands of light years in just a few seconds. For the people on Earth, several thousand years may have passed. Length contraction is a crucial phenomenon, but it's a bit challenging to grasp. To understand why, imagine passing by a planet. As we rapidly move forward, we'll see that the length of the planet has contracted. However, don't forget that the farther we look into space, the farther we look into the past. From our perspective, the edges of the planet we are passing by are curved and shaped like an ellipse. This is because the image of the planet that reaches us is a past image, and images reach us with a slight delay. If we continue to move at the speed of light, what will we see? This is a question that has intrigued our minds today. You should know that the answer is negative, and reaching the speed of light is impossible. However, perhaps if we could somehow circumvent the laws of physics, it might become feasible. The theory of general relativity tells us that space-time is like a dynamic fabric that can bend in different ways. We can imagine creating a bubble around our spaceship and then pushing it faster than the speed of light. This idea is called a warp drive, inspired by science fiction. With a warp drive, it wouldn't be about zooming a vehicle through space. Instead, it's like propelling the fabric of space itself. Our spaceship would stay still, riding on a wave of faster-than-light space-time. If you're interested in learning more about the warp drive, please watch the warp drive video on the channel. Thank you for being with us.